Welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's seminar is part of our NGSS series, and it is titled Evaluating Resources for NGSS, the EQuiP Rubric. Our presenters are Brian Reiser and Joe Krajcik. My name is Ted Willard, and my name is Sue Hokinen, and I will be moderating today's program. Jeff Lehman is also online with us to provide technical support. I want to remind you to visit the NSTA Learning Center, your online portal for professional learning and over 11,600 resources for science educators. You'll find that 4,000 of those resources are free, and you can add them to your library to access when it's convenient for you. You can organize your resources by bundling them into collections or access thousands of other collections made by NSTA and other teachers just like you. Join the conversation in the community forums where you can discuss content and classroom issues with other teachers, and our online advisors are available to help you find the information you are looking for. And you can use the free tools with the NSTA to help you organize your own professional development and meet your learning and teaching goals. It is all available at learningcenter.nsta.org. And now I'd like to introduce today's presenters. First, Ted Willard, Director of NGSS at NSTA with the National Science Teacher Association. We are also joined by Brian Reiser, Professor of Learning Sciences, School of Education, Northwestern University, and also by Joe Krajcik, Director of CREATE for STEM Institute, Michigan State University. And we will start today's web seminar with Ted. Welcome, Ted.
Thanks very much, Susan. I'm very happy to be here. Thanks everyone for coming out here today and to listen in. We'll get started here and just give you a quick overview of the standards. A lot of you probably are aware of this already, but just so we're all on the same page. The standards themselves were developed by 4 organizations. You've got the National Academies, Achieve, the American Association for the Advancement of Science, and my favorite, the National Science Teachers Association. And there was a 2-step process which involved the development of the framework. And we'll talk some more about that, and the standards. And then that led into a number of different elements, curriculum, instruction, assessment, pre-service education, and professional learning. All of these different things are in some way influenced by the standards. So let's think first about the framework. As I said, the Academy finished it off in 2011. And if you're familiar with the framework, you know there are 3 big pieces here. There's science and engineering practices, cross-cutting concepts, and disciplinary core ideas. These 3 dimensions that the framework describes and how they all play a role in science education. If you've not read the framework yet, you really should. There's no excuse. You can get a free PDF from the National Academies, or you can get, if you like a hard copy, you're looking for some great beach reading this summer, when you're going out, you can get a copy from NSTA Press. And so the first of these 3 dimensions, the science and engineering practices, so sort of the stars of NGSS, I think. You've got pieces like developing models, analyzing and interpreting data, constructing explanations, engaging in argument from evidence. These are the things that we want students to do in order to investigate the world around them. And this is what scientists and engineers do in the real world. It's what students need to be doing in the classroom. We have the cross-cutting concepts, things like patterns, scale, systems, structure, and function. These are ideas that are not unique to biology or chemistry or physics, but cut across all of the different sciences. And that's what gives power when students understand them. And then the pieces most people are probably the most familiar with are the disciplinary core ideas themselves, life science, physical science, earth and space science, and then we have engineering and technology, which is an equal partner in this whole endeavor of understanding. So that science and engineering are tied together. Each of those disciplines gets moved down into more detail, so we have matter and its interactions, and then broken down even to greater detail. Now, all of those aspects I just described to you were described in the framework, and then the writers of the standards had to work on that. And so the standards themselves was a process. It involved lead state partners from all of these different states that you see in blue here. and each state had teams, and they provided feedback throughout the process. Then you have the various writers with standards, again, spread across the country and showing sort of a really national process in all of this. And once the standards are completed, we're now in the stage where any state can choose to adopt. We certainly currently have 12 states plus DC, and so you can probably see your state listed there. And all states have the choice to adopt, and others are in various processes in doing that. And even states that haven't adopted yet, the teachers are making a great deal of use of the standards in the framework to guide how they can improve instruction in their schools. So that leads us to about 3 in 10 students now live in states that have adopted NGSS. And so let's take a look at what the standards look like. And here's a sample. We have developed molecular models of reactants and products to support the explanation that atoms, and therefore mass, are conserved in chemical reactions. And so this is the statement of what we want students to do at the end of instruction. This is describing what is to be assessed, as I note at the bottom down here. They're not instructional strategies or objectives for a single lesson. Students are going to need to engage in a lot of different activities, using a lot of different practices to gain an understanding of these core ideas, these cross-cutting concepts, and be prepared to carry out this performance expectation at the end of instruction. But in assessing that performance expectation, we can find that gives an opportunity to look at the practices, developing molecular models to support an explanation. It deals with certain core ideas, such as the idea of reactants and products, and that atoms and therefore mass are conserved in the chemical reaction, and the cross-cutting concept about matter being conserved in physical and chemical processes, such as a chemical reaction. And so all of these different pieces here, by assessing this performance expectation, we gain a sense of what students know and are able to do about all the different elements in this box. And with that, I'm going to pass things off to Joe and Brian and help to give you some understanding of way to review materials for NGSS.
Thank you, Ted. So Joe and I are going to talk today about the EQuiP Rubric, and EQuiP stands for Educators Evaluating Quality Instructional Products. And this rubric was developed by Achieve and the NSTA, involving many of the writers from the framework and NGSS. And the general challenge that is being undertaken with this rubric is we're in a position now where we're trying to bring NGSS into our K-12 classrooms. And the question is, when we look at curriculum materials, when we find lessons that are on the web, how do we evaluate them to see whether they really reflect the vision of the framework and of the next generation science standards, and reflect that vision in a way that is more than just a superficial connection? So if we see, for example, that chemical reactions are in middle school, does that mean that any lesson we find that deals with chemical reactions is fair game and is in alignment with NGSS? So that's what EQuiP is going to help us to sort of work through. It's designed to look at individual lessons, at sequences of lessons, or entire units. And the big question, again, is how well do they represent not just the subject matter that NGSS talks about, but the important shifts that are involved in achieving NGSS. So what we're going to do today is to talk through part of the EQuiP rubric. You can see in this slide that there are 3 columns. There's the alignment to NGSS, the instructional supports, and monitoring student progress. What we're going to focus on today are the alignment to NGSS, which basically has 2 parts. The first issue is evaluating the lesson or sequence of lessons to see if the lesson reflects the 3-dimensional learning. Ted talked about the 3 different dimensions that are involved in articulating the performance expectations. To what extent are the learners in the lesson being involved in engaging in all 3 dimensions in a way that reflects them coming together? And then the second issue is the coherence. To what extent are the lessons engaging the learners in a coherent treatment of the disciplinary core ideas and the practices and the cross-cutting concepts? how are the connections being made between the ideas, both within the lesson and between lessons.
Thanks, Brian. Before we continue, you should have received 3 handouts from Jeff. And I'm not exactly sure if you received those 3 handouts, but receiving the handouts are actually really critical for this session. So if you did not receive one of the handouts, for instance, is the EQuiP Rubric, and we are going to be making reference to it, so that you really need to have that. So if you did not get those, I just saw someone just say no handouts, and perhaps Jeff will take care of that. There's someone else.
Jeff is working on it. I'm sorry, Joe. I posted a link to the collection in the NSTA Learning Center. I do not have those links. Jeff has those. But I posted a link in the chat area to the collection, and they should be in the NGSS collection. But as soon as Jeff is off the phone, he has promised that he will get the handouts out to the participants. So if you, there we go. Here, we should have them now.
Okay.
Go ahead and click yes that you want to save. Everyone should see the same box that I see. Click yes that you want to save, and then you will have access to those handouts.
Great. Well, there should have been 3 handouts that you received. So as Brian and I speak, I'll be speaking now for the next couple of minutes, but you should look at, just get those handouts organized. One of those handouts, indeed, is the EQuiP Rubric. And as we talk today, I will be actually making reference to it. Perhaps one of the most important aspects of NGSS that the EQuiP Rubric builds off of is the notion of 3-dimensional learning. So it's really important, if you're going to use the EQuiP Rubric, to understand what that is. And so I'm going to just speak a little bit about what 3-dimensional learning is. 3-dimensional learning takes the 3 dimensions that Ted mentioned in his opening remarks: core ideas, cross-cutting concepts, and scientific engineering practice. Those 3 dimensions need to work together to focus instruction and assessments. In many ways, 3-dimensional learning shifts the focus on what happens in science classrooms to create environments where students actually use the core ideas, cross-cutting concepts, and scientific practices to explore ideas and use science ideas to explain how and why phenomena occur and or design solutions to problems. So 3-dimensional learning is that working together in order to do something with it. It's to explain phenomena, design solutions to problems. And in many respects, it's shifting, it's changing what happens in classrooms. In the past, when we often did inquiry in the classroom, it was in the service of learning a science idea. 3-dimensional learning changes that. The shift is using practices, the core idea and cross-cutting concepts to explain phenomena. So it's a shift away. It's to exploring the world, to examining the world. I often like to use this analogy of cooking in 3-dimensional learning. Some of those who are online who know me know that I really love to cook, and I particularly really love to cook for other people. I really love to prepare a really delicious meal. That's my outcome. That's like 3-dimensional learning. I want kids to be able to use core ideas, practices, and cross-cutting concepts to explain phenomena or design a solution of a problem. That's where I want kids to go, and this analogy of cooking is where I want to get to as well, as an analogy. So I want to prepare this really good meal. Well, what does it take for me to prepare this really good meal so that you would really have just a wonderful dinner? Well, one thing it takes is I really have to know something about how to use various kitchen practices, kitchen tools. If I'm going to fry something up, I really have to know how to get the temperature of my frying pan at the right temperature. Otherwise, I'm going to either undercook it or I'm going to burn it. So knowing how to get that skillet at the right temperature is critical. Those are my practices. On the other hand, I really know I have to have these important basic ingredients. Those are my core ideas. I have to know how to select a really good fish. I know how to have to be able to pick out those tomatoes so they're just ripe. Pick out the vegetables that just taste really good. So if I can pick out these core ingredients and I have these kitchen skills, I can make something that tastes actually pretty good. But it's not great. It's really not going to be satisfying. Why not? Well, it's because I'm missing my herbs and my spices and my seasoning. Those herbs, spices, and seasoning, I'm going to use different ones, but they cut across the meals really to bring out that flavor. So when I want to really create a really good meal, I have to have practices, my kitchen techniques. I have to pick out the really good stuff, and I need these spices that cut across to get that good meal. The same thing is true in three-dimensional learning. Kids have to use together practices, core ideas, and cross-cutting concepts in order to be able to explain a phenomena. Often if I'm doing this talk live, I like to challenge people to come up with their own three-dimensional learning, example of three-dimensional learning. And I want to challenge you after this talk to create an analogy of three-dimensional learning and send it back to me, and I'll sort of talk to you about it. So I'd love to see your analogy of three-dimensional learning. So, and the reason why we wanted to focus on this notion of three-dimensional learning is because it's central to the EQuiP Rubric and to the alignment of NGSS. So you'll notice and you should open up your EQuiP Rubric right now and look at the first column. You will see there that it says the lesson or unit aligns with the conceptual shifts of NGSS, elements of the science and engineering practice, disciplinary core idea, cross-cutting concepts work together to support students in three-dimensional learning to make sense of phenomena or design solutions. So you see, understanding what three-dimensional learning is, that working together, is critical to the EQuiP Rubric. And that's the first decision that you have to make. In many respects, what Brian and I will argue today is that if something doesn't align to this first column, there's no reason to go on to the second and third column. Making sure that the unit or lessons that you're evaluating really meet this three-dimensional focus and also have the coherence is critical in judging any set of materials. Now, when to support in judging these ideas, you sort of want to break this down into three parts. And you can look at it in respect to say, do those particular materials provide opportunities to use specific elements of the practice to make sense of a phenomena or design solution? And in doing that, here's a couple of questions you might want to ask for yourself. You could say, is that element of the practice explicitly stated in the materials? Another question you could ask yourself is, do the materials clearly point out how the students use the element of the practice to make sense of phenomena or design solutions? So those are some important questions to ask yourself. Similarly, you could say, do those materials provide opportunities to construct and use specific elements of the disciplinary core ideas to make sense of phenomena or design solutions? And you want to ask the two questions again that are listed below. Is that element of the DCI explicitly stated? Do the materials explicitly point out how students use that element of the disciplinary core idea? And then the third component of that is, do they provide opportunities to construct and use specific elements of the cross-cutting concept to make sense of the phenomena or design solution? And again, you want to check off these, you want to think about these little questions. So this is the first aspect that you really need to consider, and it's critical to really see, and it's not that you can see a practice isolated from the core idea. All three of those parts have to be working together. That's the critical aspect, that they work together. And so what we're going to do right now is we're going to actually look at some materials, and we're going to engage you in a phenomena to see what happens. And so I'm going to engage you in a unit that basically has a larger overall unit structure of how can I make new things from old things. And we've actually done a series of activities already. We're about 5 weeks into this unit, 4 or 5 weeks into this unit. And we've learned about properties of materials, as you'll see in a second. But the question we're going to explore right now is, what do you think might happen when you mix substances together with other substances? And then how would you know whether new substances are formed? These are the two questions that we're going to sort of examine. And you should have two other handouts that you can look at as I go through this. One of the handouts focuses on, there are a set of student materials that you're actually going to be using. And I want you to sort of examine those. And as I talk, there's a more longer set of teacher materials that you should try and skim. So there's both student materials and teacher materials that you're going to evaluate as we go through. You're going to make a decision. Does this lesson that I'm providing you actually engage you in three-dimensional learning? Are practices, core ideas, and cross-cutting concepts working together? So in the materials that we were, as a class, we've already learned a couple of ideas, really important ideas. From 6th grade, or a previous unit, we've learned already that matter is composed of atoms and molecules that are in constant motion. We've also learned that substances can exist in solid, liquid, or gaseous states. And this is a really important one for this lesson. Well, actually, all these are important, but this next one's critical. Substances have characteristic properties that help identify a substance and distinguish them from one another. We know certain properties. So we know certain characteristic properties of certain materials. Solubility, density, melting point are properties of substances. And we've actually been working with baking soda, road salt, and sugar. Actually, I left sugar out in a previous investigation. And we know that both baking soda, road salt, and sugar are soluble in water. So these are all ideas that we've learned up to this point. And now I'm going to engage you in what happens when I mix things together. Now, in this next slide, you're going to notice that I don't have my goggles on. And I'm going to really apologize right now. I'm not modeling good science teaching practice. I recognize that. I did not have time, however, to redo this video, so I apologize for that. I have to tell you, as a former chemistry teacher and someone who loves chemistry and doing things in classrooms, I always wear my goggles when I demonstrate. So right now I don't have it. So just be aware that I don't have my goggles on. So we're going to basically make a decision. I want you to make some observations. I'm going to tell you that because we're not going to see this full series of the videos, but we're going to look at baking sugar and we're going to make some observations on it. Road salt, calcium carbonate, and calcium chloride. I'm sorry, baking soda, road salt, calcium chloride, and then baking soda, sodium carbonate, and then water. And of course, we know that powdered sugar is a white, flaky kind of material. We have road salt, which is a white, crystalline kind of material, and then we have baking soda that's a white powder. So that's what these things look like initially. And of course, we have water, which is a clear liquid. Those were some observations that we've made. And I'm now going to take you into the task. I've actually mixed all these three solids together. And when I mixed those three solids together, not much happened. And I'm now going to tip over some. I put them all in a bag, and the bag is all sealed, as you can see on the screen there. And now I'm going to tip over the water container that's in there, and we're going to observe what happens. So Suzanne, if you could play the video, that would be great.
I sure will. And what's going to happen is I am going to actually open up or push this out to you. So this should come out to you. And then it should open up in a separate window. When you are done watching the video, please come back in and give us a green check.
What might happen when I do that? I'll set the bag looks very different than it did before.
Okay, I just want to tell you that I have posted the video link in the chat area also, so you can click on that to watch it. If not now, you can watch it at another time. When you are done, the check marks are at the very top. If you're new to Blackboard platform, it's up underneath your name at the very top. Once you're done viewing the video, if you can give us a green check to let us know that you're back in the room, that's helpful. And then, Joe, when you're ready, just don't forget to turn your mic back on again.
Okay, so people didn't hear that last part because my mic was turned off. So we just finished collecting, we just finished reacting these three things, and we saw the bag become very puffy. So when I mixed the baking soda, the road salt, and the sugar, and I added the water, we saw the bag expand. And what we're now going to do is test the materials. So Suzanne, if you could play the next video, we can see what happens when I test that. A burning piece of wood, and my assistant here is going to open this bag up, and I'm going to put it inside the bag, and you'll notice as soon as I put it inside the bag, okay, so we now tested what was inside that bag, and we noticed that when I put a flame inside this bag that was filled with a gas, it went out, and so we can make some speculations about what might be that gas, given what I started with. And of course, we could ask ourselves, is it oxygen? Well, we know if it was oxygen, it would have made the flame even burn brighter. If it was hydrogen, we would have had a minor explosion, a little poof. If it was something like carbon dioxide, it would have went out. So you might want to make a tentative conclusion that the gas that was inside that bag was carbon dioxide. And in the last, I'm not going to play the last video, but you can play it later. One of the things that is shown in the last video is that if you remember, the baking soda, the sugar, and the rock salt were all soluble in water. But when I mixed all three of them together, I don't get there's actually something that's not soluble within the bag, and you can see from the image that it actually sinks to the bottom. So the question now becomes, what happens when I mix all three of those things together? And I want you to write a scientific explanation. All scientific explanations answer a question, and they're explaining what happens. So we're going to use a format of a claim, evidence, and reasoning, but our goal here is actually to provide an explanation. What happened when I put all three of those things together? So I want you to write a claim, and because of time, you're not going to actually be able to do this. You're actually making a judgment if I'm engaging you in three-dimensional learning, but you can have, I want you to write a claim, which is a statement that responds to the original question. I want you to be able to provide evidence, which basically will support my claim from all the data we collected. And then I want you to provide reasoning, which basically links your data to your claim, making that data into evidence. And in doing so, you're actually using scientific principles to justify why that data supports your claim. And so that's what I would take as a scientific explanation, because you're trying to answer that question, what happened when I mix these three things together? Here's actually a response that I had that's scanned in front of you, and you can see the claim is new substances were formed by mixing baking soda, calcium chloride, and powdered sugar and water. The person provided evidence. When the substances were mixed, we observed fizzing and bubbling, indicating the production. The bag expanded due to the gas production. The bag became very warm during the release of energy. And then they try to, the person wrote some reasoning there. The production of a gas and the release of energy are indicators of a chemical reaction taking place. As a result of this reaction, new substances are formed, and bonds are broken and rearranged. This person actually went beyond where I wanted them to go. And then they asked a new question: what was created in its reaction? And another question: what were the quantities important in causing the reaction to occur? So one of the things that Brian and I would like you to do is, looking at what I just took you through, looking at the student materials that you were given, looking at the teacher materials that you actually were given as well. We want you to make a decision: were you engaged in three-dimensional learning? And the performance expectation that I was trying to help you build towards was the following: analyze and interpreting data on the properties of substances before and after the substance interact to determine if a chemical reaction occurs. And of course, below that, you can see the performance expectation. Down here, you can see the core idea, and you can see the pattern. Now, in instruction, we always want to build towards the performance expectation. And I really like this example of the scaffolding building towards the performance expectation, because we should never think that in one lesson we're going to reach a performance expectation. It's almost impossible. What's present in these performance expectations is really fairly sophisticated. If I really try to unpack or break down this performance expectation, there's various parts, and you can never think that in one lesson I'm going to get to all this. So for instance, just related to the core ideas, there's notions of properties of substances. Kids have to learn that. There's this notion of before and after the substances interact, and what do we mean by a chemical reaction? So you shouldn't think that in any one given case, kids are really going to learn all those ideas. And particularly when you look at this cross-cutting concepts, macroscopic patterns are related to the nature of microscopic and atomic level structures. This is a very sophisticated chemical reaction. So one lesson isn't going to get us anywhere, or it shouldn't necessarily get us to the performance expectation. But what we should be able to think about is it building towards that performance expectation? That's the critical aspects. When you're evaluating materials with the EQuiP rubric, trying to make this judgment about alignment, do you see this building towards a performance expectation? And so once again, you want to look to see if there's a blending of the DCI and the cross-cutting concept with a variety of practices to build towards that performance expectation. That's what we should expect to see in any given one lesson, or any given series of lessons, not just one lesson, but a series of lessons, a unit, this building towards by a blending of DCI's cross-cutting concepts with the elements, with variety of practices. So I could take the elements of the DCI that I was working on, the structure and properties of matter, with that cross-cutting pattern, and I could mix it with, for instance, the one I just did, construct an explanation and design solution. It's very appropriate as I'm trying to build towards it to add this one related to construct an explanation. In so doing, I was involved in analyzing and interpreting data. In order to actually write that scientific explanation, you needed to be involved in the process of analyzing and interpreting data. You may have been involved in involved in argument for evidence, because you could have been arguing about what should we actually include here? What's really evidence? You would have noticed, for instance, that teacher cited the evolution of the temperature change. It got hotter, or that example I gave you. The temperature got hotter. Is that really evidence that a chemical reaction occurred? When I mix other things together, do I actually, can I get a temperature change? So we could have been involved in argument. And then finally, you could have asked new questions like, what was formed as a result of mixing those three things together? Or was the sugar really necessary? Or was the calcium chloride really necessary? What was really necessary to get that reaction to occur? So blending, often when you're trying to build towards a performance expectation, you always want to blend various practices with the elements of the disciplinary core ideas and the element of the cross-cutting concept. And that takes us over to Brian.
Okay, thank you, Joe. So what we want to do now is to have you think a bit about what you just saw. We know we went through it quickly, but think about what we just saw, and let's now try and apply this first column of the EQuiP rubric to the lesson that we've just sort of zoomed through. And what we're going to do is start with that upper left quadrant, which talks about the three-dimensional learning. And the very first part, A, is to ask ourselves a question about the science and engineering practices. Do we see in this lesson the opportunity to use aspects of or elements of the science or engineering practices to make sense of the phenomena or to design solutions? And so what we want to see are whether that's clearly pointed out for students, for teachers to support with students, and whether the practice is there not just in a way that's thrown in, but it's really helping us get to the disciplinary core idea. So what we want is to have you respond using the poll tool and just answer what you would answer to 1A, yes or no.
Okay, and if you're just joining us, or if this is your first time on an NSTA web seminar, you're going to look underneath your name at the very top. You should see 4 boxes going across. To the far right, there should be a check mark. If you mouse over that, you'll have an opportunity to select either a green check or a red X. So if you can go ahead and make your choice and respond to the poll. And whenever you're ready, you can let me know, and I can lock the results, and I can actually publish them to the whiteboard if you'd like.
Great, that would be great.
So Brian, Diana asked a question just to provide that other people might be wondering about, just to make clear here. You're asking about this materials piece here. What materials do you want the participants to be looking at? Are you talking about the videos that Joe showed, or the actual written materials that were in the collection?
Right, okay, sorry. In principle, what we would be doing when we're analyzing, say we downloaded a lesson or we're looking at some curriculum materials that the publishers are saying, hey, we have an NGSS sticker on our published materials, they're definitely aligned. You want to look at the written materials that we would be using to guide the teachers and the students. So if there's for what we have now, the teacher lesson plan and the student materials, one would want to analyze both. We know that not everybody got the downloads, but that's what, in principle, using the EQuiP rubric, you'd be analyzing. So not everyone has voted yet, but why don't we lock the results and just display what the results are? So it looks like 13 people said no and 119 people said yes. If we had more time, I would love to hear some justifications from those who voted yes and those who voted no. I can tell you what Joe and I would have voted. I think for this one, what we would be doing is comparing what we saw in terms of the thinking and reasoning and talking being demanded of the students, compare that to what is articulated in the science practices. And I think by asking the kids to develop a scientific explanation, to defend using evidence why they are asserting that a chemical reaction has occurred, I think we would be saying that we are definitely involving the science and engineering practices here. Not only the ones that are in the performance expectation of analyzing the data, but other practices as well. So let's go on and, in the interest of time, look at the next aspect, which is, what about the disciplinary core ideas? So if we think that the practices are involved in a way in this lesson, what about these disciplinary core ideas? And just to remind you, because we don't have the performance expectation in front of us right now on the screen, the disciplinary core ideas talked about what happens when a chemical reaction occurs and how the atoms are regrouped and the properties of the resulting substances may change. So let's go ahead and say yes or no. Do you think that this lesson provides opportunities to construct and use elements of the disciplinary core ideas to make sense of phenomena or design solutions?
Okay, and again, we're going to use the same polling button up near the top underneath your name, a green check for yes, a red X for no. And whenever you're ready, just let me know and I will lock the responses for you.
All right, I'm just watching the numbers here, and it looks like the numbers of votes are tapering off. Let's give people another 10 seconds. Okay, so let's see the results. All right, so 12 people said no and 115 people said yes. 111 were holding their vote in reserve, wanting to think more about it. And let us just say also, again, in the interest of time, this is sort of a whirlwind tour. When I'm sitting down with the EQuiP rubric, or when we're working with teachers and doing this for real, you'd have a lot more than a minute or two to make this decision, because you want to pour over the materials and figure out what really are we pushing the kids to do, what intellectual work are they doing, and what is the teacher or the curriculum materials sort of providing to them. And we then want to do some careful looking at what is in the disciplinary core idea, both in the performance expectation, and often we need to go back and look at the framework to see that the context in which that description of the piece of the science it's talking about was presented. So we're asking you to make a pretty quick decision here. And I think both Joe and I would agree with the yes votes here, that some of the key parts of what the disciplinary core idea are, we're helping kids build toward. We wouldn't say that we've achieved this disciplinary core idea at the end of this lesson. This is just part of a larger trajectory. We didn't really push kids in their explanations to talk about what the atoms are doing and why that's responsible for new properties, but we did. We are seeing in the example student work that Joe showed the recognition that we are getting new substances with new properties based on the fact that a chemical reaction has occurred. So let's go ahead and look at the third part of the three-dimensional learning, which is the cross-cutting concepts. And again, we're going to ask the same question now about those cross-cutting concepts. Do we feel that this lesson has provided opportunities to develop and use those elements of the cross-cutting concepts to make sense of the phenomena? And the cross-cutting concepts over there on the right in the performance expectation in the green area talked about patterns and explaining patterns in terms of the connections between the macroscopic or the observable level and the microscopic level. So let's use the same poll and vote yes or no.
And again, we want to use the green check for yes, red check for no, and just let me know when you're ready to have the responses locked and published.
All right, why don't we give people another 15 seconds? Okay, let's see what the results say. So on this third dimension of the cross-cutting concepts, we have more of a split decision here. We have 44 people saying no, 71 people saying yes, and a lot of abstentions. And I think that one could make arguments on both sides, but I think Joe and I would probably have voted, not quite yet or no on this one, because there's definitely the potential to connect what we observe at the macroscopic level with the microscopic level, but we're not. If you look at the lesson plan, it's not really called out, and we're certainly not bringing it out of the specific chemical reaction context to try and get to a more general cross-cutting concept here. And so that may be completely appropriate when we're looking at one lesson sort of out of context. You might not see much evidence of getting to the cross-cutting idea, but in this case, I think we would have had to have voted no. So if we were to put together the three judgments, which is really the goal, are we engaging kids in three-dimensional learning? The goal in using the EQuIP rubric is not to do a thumbs up or a thumbs down vote. It's to figure out how could we improve this lesson or this series of lessons to better get at three-dimensional learning. And I think what we would say is we've got a nice blending of the practice and the disciplinary core idea. They are really working together here. You're not just writing the explanation because we were told to. The explanation is really helping us get at the phenomena that we just saw and getting it to the important science content. But the part that we would want to improve is the connection to the cross-cutting concept. So now what we want to do is to move on to the second part of that first column, which is this coherence issue. And as someone pointed out in the chat window, it can be difficult to figure out if I have an individual lesson, how do I tell that it fits coherently into a larger picture? But there are certain things that, and so this criterion makes a lot more sense if we're looking at a series of lessons. So we want to talk a little bit about what you might do if you had a series of lessons and we're evaluating coherence. And there are three aspects of this that we want to look for. The first one is, so does this piece fit into a larger sequence coherently? And we're going to talk about that in terms of the storyline. The second thing is, where it's appropriate and productive, are we making the connections between different science disciplines, between, say, the chemistry and the physics of the situation, or between the chemistry and the biology of the situation? And then where it's appropriate, are we making great appropriate connections to Common Core standards in math and or in language arts? So those are three separate questions that one might ask in looking at coherence. And here in pushing on that first one, we want to see that the lessons are fitting together coherently, building on each other, and helping students get to these targeted set of performance expectations. And the kind of questions that one might ask here are, do students know why they're doing what they're doing? Do they see how what they're trying to figure out in this particular lesson fits into a larger storyline, fits into some set of phenomena that we've been trying to make sense of, or a solution that we're trying to develop? So let's think about that, and what we're going to do is to think about not just an individual lesson, but how a lesson might fit into a larger sequence. And this is sort of an abstract representation of some of the ways that can play out. One thing that might be helpful to think about is, do I have a question connected to the phenomenon that I'm looking at? If I'm seeing substances combine, am I being pushed to think about some question connected with that? And then am I engaged in some practices to work with and try and explain that phenomenon, whether it's analyzing data or explaining or arguing or developing a model. And then do I take whatever I figure out, articulate it, are the students pushed to articulate it, and is that then linked to the next phenomenon and question that I'm going to look at, so that across the lessons, we're adding to and extending our explanations or our models or our design solution to put the pieces together across the lessons. That's sort of, in the abstract, how we can think about what coherence would look like for a series of lessons. And in this case, what we're representing on this page is the sequence of lessons in which that experiment that Joe just walked you through takes place. In here, we're asking about the properties when substances combine. And that's in the context, as Joe said, we've already been working for a number of weeks on a set of phenomena where we were trying to figure out how I can change certain things into other things. When can I do that? When can't I do that? How do I look at a substance to figure out whether it's a different substance from some other substance in the first place? We learn about properties in doing so. That takes us to starting to do some analyses of different substances, and now starting to think about, in this case, what happens if I start to mix these substances together. Let me talk through a second example. We're not going to have you vote on the coherence of that lesson because we only showed you the one lesson. Here's another example from a different subject matter, also drawn from middle school, as the chemical reactions study was drawn from. And it's just to give you another example of ways that lessons can build on one another. We would argue, Joe and I, in a coherent way, where in each case there's a question that I'm worried about, and this is a case where we're looking at the human body and learning about human body systems. And instead of thinking about coherence from the disciplinary core idea perspective, okay, what are the important systems in the human body? Let's take this system, let's take the next system, let's take a third system and look through it, and then figure out what's going on with the cells, what's going on with structure function, etc. From the student's perspective, the coherence is we have a question we're trying to figure out. In this case, we're trying to figure out how our bodies get the energy that they need to do the things that we know our bodies can do. And that the particular path that the class develops is to look at, since they know from earlier work that we get energy out of food, we're going to trace the food through the body and find out where the food is going and where we get the energy out of that food and what happens to do that. And so rather than looking system by system, because the next chapter says we're now moving to the skeletal system or the muscular system, we are tracing where the food goes, looking for evidence of what happens to the food and trying to figure out where energy may be released in a way that the body can use. And the ultimate solution that the kids develop across a period of 6 weeks is actually figuring out that the only thing we can realize, the only thing we can make sense of that would have produced the results that we saw along the way is there must be a chemical reaction going on. That's the only thing that we know that could have released energy and transformed it from one form to another, from the stored form to a form that the cells can use to do what we see them doing. And so when we think about the coherence question, then we're looking for not only the coherence of how the lessons built together, but we can also ask then that second question, are we building these connections between the disciplines where it makes sense, either through the use of the cross-cutting concepts or connections where the disciplinary core ideas are connected. And in this case, for example, our ideas about getting energy out of food build on earlier understandings of food from the 3 to 5 grade band, and we have the connections between, we would argue, the connections between the disciplines, in that we're drawing on this idea of conservation of energy, conservation of matter, and what happens to energy in a chemical reaction that come from the physical science strand. And so when we look at this particular storyline, for example, critical pieces of the argument came from applying ideas that we built in the physical science strand. Some ideas about molecular motion that are going to allow us to explain osmosis, conservation of matter and energy that allow us to use evidence from a particular experiment to say a chemical reaction must have occurred because now we have a gas where we didn't have a gas before, etc. So we've tried to do sort of a whirlwind tour to give you a taste of what it's like to go through trying to apply this rubric and thinking just about that first column of the looking for three-dimensional learning and looking for coherence. We see the three-dimensional learning as a really key part and something that is very easy to potentially to false alarm to in curriculum materials. Like we might see, oh, there's a practice here, oh, and there's a piece of a DCI here, and there's a piece of a cross-cutting concept. But are they really working together? And if we're doing, say, a whole week's worth of work and the practice doesn't show up until Friday, we might worry about whether that's really three-dimensional learning or whether that practice is just thrown in there in a superficial way. And a lot of the action in using the EQuIP rubric comes in interpreting how we look for these three-dimensional learning ideas and how we look for the curriculum coherence. But both of those pieces are really key in figuring out whether, before we look at instructional support and before we look at the way assessment is built in, are we involving the kids in the kind of learning that the NGSS is really calling for? So with that, we just wanted to say a quick thanks. The iQuest materials are where we drew our examples from. And actually, Joe, I'm going to turn things over to you. Sorry.
Joe, we need your mic on. Try again.
Okay, so I'm going to just go back a slide just to make some other points. Brian and I, as he said, we focused on the first column. And it's not that the other columns are not important. In fact, they're very important. If you look at the EQuIP rubric and you look at the instructional support column, column 2, it really deals with some very important issues. Like really, if you look at the first bullet, for instance, it says engaging students in authentic and meaningful scenarios that reflect the practice of science and engineering as experienced in the real world in order to make sense of phenomena. That's an incredibly important criteria that you have to make a judgment for. If you go down a little bit, and you'll see uses scientifically accurate and grade appropriate scientific information, phenomena, and representations to support students in three-dimensional learning. So this second column is critical. The third column, if you look at it, deals with assessment. It's also very important, and it basically says, are there opportunities in class to provide formative assessments where kids are actually using those three dimensions together? So these second and third column are very, very important, but unless they really meet those criteria of alignment, unless the lessons or a series of lessons match up to three-dimensional learning, and unless you can really see that coherence where the lessons are carefully building upon one another to really support kids in explaining phenomena and designing solutions to problems, and their reasoning and thinking gets more sophisticated, there's no reason to go on. That first column is where you have to really take your time and really make some really important decisions with respect to going further with EQuIP, going further with those materials and making those decisions. And really understanding, to me, that the hope is that we can see that shift. It's a subtle shift in thinking, but that shift in thinking is one that instead of using a practice to help kids learn a core idea in a cross-cutting concept, or using a cross-cutting concept and a practice to learn a core idea, those three things are working together. They build together to give you something more than what was there before to allow kids to use that knowledge in order to do something. Explain a phenomena, solve a problem, learn something new. That's where the hope is. And you, as teachers, are going to have to make those decisions about materials. I can guarantee you that every publisher, particularly if you live in a state that has adopted NGSS, will have a rubber stamp that they meet NGSS. They will have gone through and made check marks and said, we meet it, we meet it, we made it. And you have to look at it very carefully and make that decision by yourself. You have to be able to look at the first level and say, do I see three-dimensional learning throughout these materials? Do I see coherence? Do I see that very careful building across time so students can make sense, make further sense of ideas? That is in order to explain or solve problems. That is just critical. So Brian and I did spend this time focusing primarily on this first column because it's so essential. Once you get there, then you can go on to that second column and see, do the materials engage kids in authentic situations? Is the material accurate? Does it provide deeper understanding of the practices in cross-cutting concepts as we're going through? But that's after you make this first decision. So this first column is perhaps the most important thing that you have to grapple with. Brian and I did want to thank Sangari for letting us use their lessons. And with that, we have a good 15 minutes for question. Often we tend to run out of time, but Brian and I wanted to make sure that we had time to go back and forth on some of your questions. I know as Brian was talking, I was scrolling through some of the comments, and I saw a lot of really interesting questions. So now it's time for questions.
Yep. Great, Joe. Thank you very much. Start off here. Have a question you just asked a minute ago. Is the rubric to just check how aligned the lesson is to NGSS, or is there a separate checklist for coherence? And they're noting they're a little confused. I think you can elaborate, but I'm thinking we're talking about that coherence is part of what alignment is all about, in the letter and the spirit of what NGSS is talking about.
Brian, I'll start off, and then you can chime in. We hope there's no, Brian and I don't see the EQuiP rubric as a checklist at all for either alignment, coherence, or any of the instructional strategies. We see it as you looking at it very carefully and making a decision and giving a rationale for why it's there or why it's not there. That said, if you look at the first column of the EQuiP rubric, and hopefully you've downloaded the EQuiP rubric because it's just too tiny to put on the screen. But if you look at the first column, it's made up of two parts. One is that does a lesson or a series of lessons engage kids in three-dimensional learning? That is, do you see the three, there's the first column. Do you see the three dimensions working together so that kids can explain phenomena or design solution? And then the second part of that, once you've made that decision, you go down and you look and you say, is there coherence? Do those lessons fit together, build on each other, make connections so that students' ideas, their practices become richer and more sophisticated so they can explain more phenomena. In the charts that Brian showed you, the coherence was actually established by kids each time grappling with a question and then building a little bit more of the understanding to answer that question that moves on to a new question. So the first column deals both with, is there three-dimensional learning and is there coherence? But don't think of it as a checklist. You want to go beyond the checklist and be able to point explicitly and show explicitly where is the three dimensions working together and where do you explicitly see the coherence. And you want to be able to show that evidence. Just like being a good scientist, we need to show good evidence. In making that decision, you want to be able to show the evidence both for the three dimensions, three-dimensionality, as well as the coherence. Brian, do you want to add a comment to that?
So that was very well said. The only thing I would add, I guess, is that in a way, these are two separate things to worry about, but you could think about that they're foregrounding two different aspects of something that is very related. The reason that coherence is so key is part of what it means to have three-dimensional learning. You're not really engaged in the science practice unless you know why you're doing what you're doing. You're not really engaged in analyzing and interpreting data, for example, unless there's some question about some phenomenon that you're trying to figure out, or there's some aspect of a design solution you're trying to work on and improve. So the idea of the practices being integrally connected to the disciplinary core ideas and the cross-cutting ideas means that you need this coherence across lessons where we're building ideas piecemeal over time, and we know what we're trying to figure out, and we're not just analyzing some data or designing an experiment because the teacher says that's what we're supposed to work on today.
Great. So another question here. I'm actually going to throw two pieces at you together because I think they tie up nicely. Are you saying that if a lesson doesn't sufficiently meet the criteria for column 1, there is no reason to worry about the other two columns? And then, tied into that, are you saying that if a lesson doesn't fit each of the dimensional components, it cannot be considered to be aligned and/or it should not be used at all? So can you kind of touch on those two? And I would remind you to think about cross-cutting concepts, as like the lesson we saw today. Some people were saying didn't have cross-cutting concepts captured.
So I would say that if it doesn't match up to the first column, there's really no reason to go on, because the essence to me, and I'll let Brian chime in his part as well, to me the essence of NGSS is the blending of core concepts, practices, and cross-cutting concepts together so kids can make sense, can explain phenomena, or design solutions to problems. That to me is really, there's a lot of shifts in NGSS, but when I stop and I think about what's really unique, it's this blending together the three ideas. We had practices back in the days of NRC, the National Science Education Standards, and with AAAS, the benchmarks for all students, but they were separate. They weren't working together. We had standards for practice, for inquiry, and we had standards for the disciplinary ideas in some respects. There was never any thought that these two things really work together, or the three things work together: cross-cutting concepts, practices, and core ideas. So to me, that's the essence. And if that criteria is not met, then to me, you can't go on. Then I would go on, and then if it's incoherent, I wouldn't go on either, right? So and in some respects, you're going to, I would hope that if you have these three dimensions working together, you also have coherence in it. So for me, you don't go on unless that first column is met. Now that said, Brian and I picked the lesson today on purpose. We, as he said in his remarks, we thought it worked nicely with the scientific practice of kids actually writing out a scientific explanation. And in so doing, they were also engaged in analyzing and interpreting data, and also communicating ideas at the very least. So at least two other practices were sort of involved in that. So we thought it was a really nice example of illustrating a cross of a practice, particularly explanation, blended with various elements or components of the elements. Particularly, substances have characteristic properties, and that in a chemical reaction, the new substances that are formed have different properties. It didn't pick up that part of the atoms. That wasn't what that lesson was all about. But no one lesson is ever going to get to the whole performance expectation. So we thought the practices and the core ideas, at least part of the core ideas, the elements of the core idea, was being nicely met, but the cross-cutting concept wasn't there. A lot of people argue with me and they say, oh, it's implicitly there. Yeah, I want to see it explicit. But I wouldn't throw that lesson out. What I would rather do is give feedback to the author and say, make it more explicit. Show me how you're moving towards the practice that's the cross-cutting concept that's mentioned in the performance expectation, or what other cross-cutting concept is actually used here. You could, for instance, build on cause and effect, because in any chemical reaction, there is a cause and effect relationship. So rather than throwing it out, I would rather say, let's redesign that lesson to show how we're building towards the cross-cutting concept that's actually mentioned in the performance expectation, which is one of patterns. That at the microscope, the patterns that are visible at the macroscopic level are due to what's happening at the microscopic level. I would rather see that lesson be revised and make that more explicit rather than throwing it out. And particularly where we are nowadays. 5 years from now, that's a different story. But today, if you're getting really good practices, working with core elements of core ideas, and you see that coherence building across time, that's where you want to give people feedback and think about how can we get that cross-cutting concept in there. Brian, you want to chime in?
So let me just add a little bit to that, and I think I completely agree with Joe. And what I would caution against is thinking maybe I need to do a few lessons to establish a disciplinary core idea, and then I'll bring the practices in. And a lot of our traditional curriculum materials that are out there now do that. So while Joe is saying, well, maybe we're not getting enough to the cross-cutting concept and it might be okay, we're going to get there in a few lessons. If you were saying, I'm going to work for a few lessons on this disciplinary core idea and then bring practices in, that's, in particular, I would say, our EQuiP rubric and our question about alignment to NGSS would call foul, would say, wait, the whole reason the framework exists and the 20 to 30 years of research that it's built on is because we know that for most kids and for most complex disciplinary core ideas, you can't give the disciplinary core ideas to the kids. I know there's often a view that we should teach kids the basic knowledge and then we'll get them to do something sophisticated with it, but we know there are real problems with that for many learners. So we shouldn't be seeing a lesson and saying, oh, okay, this lesson 1, 2, and 3 are really good at the DCI, but we're not getting to the practice. I think that's in particular what we're trying to guard against.
Great, thanks. I'm just going to quickly just touch on one comment in the that's gone on in the chat here before I pass your next question. So some people who are feeling a little bit, I think, overwhelmed in how can we do all of this at once, and that I think an important piece for all of us to understand is that it's going to be a multi-year process for all of us in terms of really mastering what's going on here. But every step we take in the direction of combining practices and core ideas and cross-cutting concepts together, in having students really engaging in sense-making and discourse with each other, these are things that will improve instruction, even if we do it in baby steps, and we don't have to necessarily tackle it all, all in once. Also, sort of hit on 2 questions that have came up that are sort of more NSTA questions. People who are asking, evaluating materials like this will be very time-consuming. Is NSTA planning to provide some kind of guidance on materials like an NSTA approved seal? And will NSTA or other groups help with assessing true NGSS with new textbooks? Such assessments cannot fall on teachers. And so I'm not sure that this gets exactly to what some of the folks are asking for in terms of like a seal of approval. But NSTA is engaged in a process where we have recruited a group of 55 curators who have received some training. Joe and Brian have been involved. Some of them I think are online here today, that are familiar with the EQuiP rubric, are familiar with the standards, and each is working on a unique topic in NGSS and trying to identify materials that are useful. They're finding that there isn't a lot of stuff that is out there that can be used as is. But one of the big aspects about the EQuiP rubric and taking materials through the EQuiP rubric is this idea of seeing where the strengths of a resource are and where the weaknesses are, and then thinking about how can this be improved. And so the curators, for example, will be giving some guidance to teachers about how they could take a particular lesson that has some real potential, but move it closer towards that NGSS ideal that we're trying to get through and get to in all of this. And so I encourage you all to keep that in mind. You are not going to be able to take the rubric today, take your lessons now, and for this coming school year, and turn every one of them into a seal of approval, perfect lesson. But that's asking too much of yourself and of the education system to do that. What you can do is to see how you can start to make some changes in your instruction this coming school year that should help your students better learn than the students you had last year. So taking that, so I think Brian and Joe's patience for me sort of jumping on a soapbox there for answering a couple of pieces here. But I think that it ties nicely into this next question. Is that I understand that instruction should be three-dimensional every day during science instruction. How do you recommend that teachers start in order to begin learning to how to instruct 3D without overwhelming themselves?
So this is Brian. I think both Joe and I have answers to that probably, because we've been doing a lot of work with teachers and trying to figure out what's a good way to get started. And one could make different arguments. There are probably a lot of different ways to get started. But what I have seen work with teachers is to take something that you know pretty well, that you teach right now, where you feel like there's a pretty good alignment in terms of at least the goals involved with the disciplinary core ideas. You have a unit on ecosystems, and the thing that you feel like you're trying to get at with this ecosystems unit is pretty close to what's articulated in the disciplinary core idea. But you're feeling like we really are not getting kids to do enough of the sense-making, enough of the analyzing of data, enough of the constructing of explanatory accounts as the practices would really be asking for. So take something, not an entire year, take a few weeks of something you work on and think about how to try and build practices into it, how to figure out, say, some data that kids could work with, or some phenomenon. I think phenomena and questions are always key. What is it that, ask yourself, if we're successful and the kids develop these disciplinary core ideas, what can they explain about the world that they couldn't before? And what are some examples of phenomena or questions, things that are happening in the world that the kid who has this DCI should be able to explain? And let's work backwards from that and try and figure out phenomena that would be productive to investigate. So I think you have to try it and start small. And for me, my recommendation would be try and build practices into a unit that was more teacher-directed. And that doesn't mean we're going to let the kids free to wander around and figure stuff out. We have to figure out both how to help the kids do more of that heavy lifting, the intellectual work, but how am I going to support them in analyzing the data, in constructing an argument from the evidence, in putting pieces together in the way that the chemistry unit that Joe was describing does, so that you get to that big story across a couple of weeks. Joe?
So I would actually agree with Brian. I would start off with something small. I can tell you when I began my science career, or my science teaching career as a high school chemistry teacher, it's exactly what I did. I made this personal goal that I was going to have kids experience something at least once a week. Now maybe in NGSS it might be a little bit different, but having kids actually experience some phenomena and then say to yourself, and then ask the question, how can we explain this? And getting kids engaged in collecting data to make sense of it, construct a model or construct an explanation, and having them, every other week pick something and how can have them experience and have them say and have them collect data to make sense of that data so they can explain that phenomena. But start small. We have to start somewhere. I know I was reading one of the comments above and says we're not there yet. Absolutely, we're not there yet. We've got a long way to go. And that's why I said maybe in 5 years, we want to see all sorts of materials that have all 3 dimensions built in. But right now, I would say, we want to try to build towards it, and I would build, personally, if I was back in the classroom teaching like all of you are doing, I would want to try something once once a week, once every 2 weeks, where I'm really trying to engage kids in taking a practice and particularly blending it with a core idea. I know I constantly struggle all the time when I look at materials about how I can make the cross-cutting concept explicit. That's not really clear yet. That's actually a challenge for the field and how we really make those cross-cutting concepts explicit. But you want to have that in your back of your head, and certainly when kids are working with patterns, have them, and they see patterns, you want to point that out, that, this is a pattern. We always look for patterns to use as evidence, or if something's a cross-cutting concept, build it up. But I would start small and move towards, and then, build up from that.
Great. Thank you very much. So we're going to shift on to the sort of next pieces here. I've got a few pieces of information to pass on to you, and then we'll give you time to do your evaluation. Brian and Joe will hang around, though, and we'll have a sense for sort of some unofficial Q&A once you've had a chance to do your evaluation. But I want to point out, obviously, on the web, there's the official site, nextgenscience.org for the standards, and the NGSS at NSTA Hub, nsta.org/NGSS is the link for that. People are asking where you can find NSTA's materials and things. Everything we've got you can find from the Hub, and I'm highly biased, but I think it's probably the best place out there to find resources and information about what's going on with NGSS. Also, we can continue the conversation in a bunch of different ways here. NSTA has a member-only listserv on NGSS, as well as their discussion forums in the Learning Center devoted specifically to NGSS. We've had some great talk in the chat. I hope we can continue that in other places. I want to point out that in addition to this web seminar, we've got a huge number of archived web seminars on the practices, cross-cutting concepts, core ideas, assessment, and you also can find journal articles in all of our various journals that have dealt with NGSS. These are great resources for you to work with in the NSTA Learning Center. Next week, next Wednesday, I hope to see a bunch of you all back here for our virtual conference, Connecting Literacy and Science with NGSS and Common Core. Again, that's Wednesday, August 6th. It goes 10 a.m. to 6 p.m. Eastern Time. You don't have to be there for the entire piece all at one time if you're only able to come for part of it now. You'll be able to, if you attend, access an archive that has pieces, sessions that you've missed, including if you go to one breakout and don't get a chance to see one of the others, you'll be able to do that. And we really got some of the top people. So mentioned in the chats earlier, one of Brian and Joe's colleagues, Leanne Sutherland, will be one of the speakers. We'll talk about the iQuest material and how it can be used to tie literacy and science together. So you can find information about how to register for that. So links. And this fall, we've got a huge number of resources coming together. A number of web seminars on the elementary grades taking place once a month starting in September 17th. These are Wednesdays, the 6:30 to 8:30 p.m. Eastern Time, and looking forward to that. A number of books by NSTA Press that deal with NGSS. You can see a number of titles here. And there's also the NGSS app. Get on your cell phone or your tablet. It makes it very easy to look up the standards. We've got our fall conferences coming up this fall, and next spring we've got our National Conference and STEM Forum and other conferences coming in 2015. And so with that all in place, I will turn things over to Sue to do the thank yous and tell you how to do your evaluation.
Thank you, Ted. And before we begin the evaluation, I'd like to encourage you to give a round of applause. Up under your name at the top, there's a smiley face. If you mouse over that smiley face, not the hand, but the smiley face, you'll notice that applause is one of the options. Give a huge round of applause for Ted for his participation and presentation of the NGSS standards, Brian Reiser and Joe Krajcik for their contributions to today's web seminar. Thank you, gentlemen, very much. Very informative, very engaging. Definitely going to have to review this web seminar so that I can gain everything that you guys put out there. So thank you very much. Also like to say thank you to the Carnegie Corporation of New York for sponsoring today's program. Thank you to the administration of NSTA for their support of web seminars. You can find the resources related to today's presentation by going to the web seminar collection in the NSTA Learning Center, which will include the archive to the web seminar and the presentation slides. The collection may also include journal articles and lesson plans, interactive content modules called Science Objects and SciPacks, and links to helpful websites and multimedia. I'm going to put a link directly into the chat window for the collection. Give me just a second to highlight it here. I'm going to put that link directly into the chat area. And also, everyone who's registered for this program will receive an email within the next day or so with a link to access this archive, the archive of this web seminar, and the collection. And here's a look. Whoops. And here's a look at what's coming up on the web seminar calendar. On July 31st, we have Using the Learning Center as your e-textbook with pre-service teachers. On August 14th, Enhance your content and pedagogical knowledge using NSTA resources specific to life science. And September 3rd, Leaders for Science Education, preparing an application for the NSTA Board and Council. You can register for these upcoming programs and others by visiting learningcenter.nsta.org/webseminars. Thank you, everyone, for your participation. We look forward to seeing you again on another NSTA web seminar soon.